Hello everyone. I welcome you all in this lecture of 12th class NCERT Mathematics. In this video lecture, as you see, we will discuss chapter 7 integral of exercise 7.1 question number 1, 2 and 3. Before that, I already discussed chapter 1 and chapter 5, that is relation of function and continuity and differentiability. Differentiability is going on, okay, side by side. Now from this video lecture onwards I'll start the integral chapter. Okay, so here we have question number 1 2 3. Concept is direct integral. So without further ado, let's get started. First of all, I'll tell you what is the meaning of the integral and how we can correlate. Okay, as you study already, before starting this chapter, you have a prerequisite or you have a basic knowledge of derivative, because without if you don't know what how to differentiate what is the derivative of the some standard function, okay, then you can't proceed in this chapter. So before that, you need to complete your fifth chapter. At least basic knowledge you need to be know what is by differentiating this function you are getting this function. Okay, so now here actually what we have, suppose we have f of x, capital F of x. By differentiating this function, okay, you are getting small fx, you are getting small fx, okay. Then this process is called the derivative differentiation. Process is differentiation. With respect to x you are differentiating, clear? And this is called the derivative of capital F of f. Understood or not? Okay, but in integral we are saying that we need to integrate f of x. This is the symbol we are using for integral f of x with respect to x, writing dx. The meaning of this one is we are looking for a function capital Fx, okay, we are looking for a function capital Fx. By differentiating this function capital small fx, we are getting capital Fx, okay. By integrating this small fx, we are getting capital Fx. The meaning is when we are integrating this small fx, actually we are looking for the capital Fx. By differentiating that capital Fx, we are getting small fx, as you see here. Like if we are integrating sine of x, okay, dx, the integration means sine x we need to write here, and by differentiating which function we are getting sine x, that's why we are saying that is the inverse process of differentiation, okay. So by differentiating which function we are getting sine x, by differentiating cos x we are getting minus. This minus we can manipulate easily, okay, but the derivative, or we can write as d by dx of minus cos x, minus cos x. This minus I'll do there, wait. By differentiating minus cos x, we are getting sin x, okay, we are getting sin x. Understood or not? So hence the integral of sin of x is minus cos x, okay. But observe that not only by the differentiating minus cos x we are getting sin x, minus cos x plus 1, if we differentiate we are getting sin x, and minus cos x plus pi, if we differentiate then also we get sin x. It means for this sin x there are so many integrals are possible. So but we need to write a unique answer. How we can write all these answers? So how we can write all these integrals? So we, for that purpose we are choosing a constant c here, okay, and we are saying that minus cos x plus c is the final integral of this sin x function, okay. This is our integral, that is integral of sin x, integral of sin x with respect to x, we are getting minus cos x. I hope you understood. Okay. What is the meaning of the integral? Actually, the meaning is, I'll recap again, that we are looking for the we are looking for a function capital Fx. By differentiating that capital Fx, we are getting small fx. And how we can it? As this you can see, we from small f we are going to capital F. From small f to going, we are going to capital F. Here we have f capital Fx and we are going towards small f. That's right, a differentiation. Here we have a integration. Here we have a integration with respect to x. That's why or it is called anti-derivative. Anti-derivative. Clear? Or it is called inverse process of differentiation. Okay, there are so many meaning. Clear? This is your first one, this is your second one, and this is your third one. Okay, so without further ado, let's get started our question number 1. So question number 1 is, find an antiderivative or integral of the following function by the method of inspection only. Okay, that means how we can write, first of all, this thing I equals to sine of 2x we have, and here we have dx. How we can integrate? Okay, actually here you can see that um, you can write this thing in rough. Okay, this is your f of x. What is your f of x? Sine 2x. Okay, it means by differentiating some function we are getting sine. When we are getting, by differentiating cos, but we are getting minus sine. So what I will put? Minus cos I will put. Okay, and one more thing also is there, that differentiation of minus cos is sine. Okay, argument should be 2 or not, but you can observe that if you're differentiating minus cos 2x, we are getting minus cos 2x into 2 by the chain rule. Clear? And but here sine 2x only is there. Okay, so we need to remove that one part also. So what is our integral? Actually, we need to divide by 2 because 2 is not there. 2 is not there. Here only sine 2x is there. We need to integrate this one. So if you can see here that by differentiating this function, by differentiating this function, we are getting sine 2x. You can see derivative of cos is minus sine, minus minus plus, and differentiating 2x is 2, 2 cancel, and since we get that this one. Okay, so here you can see how we can make. Here you can see I equals to the integration will be, or you can do like that also, by the 2 you can multiply and you can divide. Here you can see minus wait 2 sine 2x. Okay, 2 sine 2x dx. Okay, and one more thing also, I equal to, can I write like that, minus 1 by 2 minus 2 sine 2x dx. Now you can see that the derivative, if you differentiating cos 2x, d by dx of cos 2x is minus 2 sin 2x we have. Clear? So the integration of this complete function, the integration of this complete function is cos 2x. I hope you understood. So here I equals to minus 1 by 2 here, and here we are getting cos 2x plus c. Okay, this is your answer. This is the integral of the first one. Okay, you can use this one. Okay, done. Now here you can see question number 2. Question number 1, I hope you understood how we are proceeding. Okay, question number 2. Question number 2, what we have? In question number 2, we need to integrate. I need to put here. We need to integrate cos 3x. Cos 3x we need to integrate. Okay. So first again, cos, when cos will come? Cos will come if we are differentiating sine function. But argument has to be same. So argument will be 3x here. Okay. By differentiating, observe. By differentiating sine 3x, we are getting 3 cos 3x. What we are getting? 3 cos 3x we are getting. Clear? So it means the integration for this function will be, first of all I need to make some manipulation here. 1 upon 3 will be here and 3 will be here, cos 3x dx. Now we have total integral, because if you are integrating, we are using integration because directly we get now. This is your cap. This is your small f, okay, and this is your capital F. This is your capital F, and this is your small f. And by differentiating capital F, we are getting small f. Hence, we are integrating small f. We are getting capital Fx. So what we'll get? I equal to the 1 by 3, and here we are getting sine 3x, and plus c is there. Plus c for some reason. Okay, I already explained that because for a given function, the integrals are many more. Clear? You can see here, I'll tell you in separate. Cos, here you can see sine 3x plus 4, sine 3x plus 5, sine 3x plus pi, sine 3x plus 9, etc. All of these has derivative 3 cos 3x. Clear? It means for this 3 cos 3x, integrals are this one, this one, this one, this one. But if we are writing particularly like that, then it will take a lot of time. So better way, we can use this c, and this c belongs to real number, that is constant of integration. C is called constant of integration. I hope you understood. Okay. So now we are moving to the third question. What is third question? E raised to the power 2x. Okay. Question number third is integral of e raised to the power 2x dx we have. You can observe here, if we are differentiating e raised to the power 2x function, will get e raised to the power 2x and multiply with 2 chain rule. Clear? Okay. So it means if integrating e raised to the power 2x, we are getting e raised to the power 2x format only. Okay. But by integrating e raised to the power 2x, we are getting e raised to the power 2x up into 2. So what we need to do here actually, we need to, because alone e raised to the power 2x, we need to integrate. Okay. So if we are integrating, we need to multiply and this one 2 e raised to the power 2x dx. Clear or not? Because the integration of e raised to the power 2x will get e raised to the power 2x, okay, and plus c is also there. So I hope you understood. Again, c is a constant of integration here. Okay, what you need to observe here in all these questions, what is common here, you first of all you need to see, you need to check that what f format is given, what small f format is given, small f format. Okay, whether it is sine, whether it is cos, whether it is sec square or something else. Okay, and by this small f, when we will get this format, you need to write that function. Clear note, by differentiating that function we are getting small f, small f. So by do some manipulation here, because constant we can manipulate only. See here you have how we are manipulating the constant here, by multiplying and divide by the 2. Purposely we are doing this thing because derivative of e raised to power 2x is e raised to power 2x into 2. Okay, here cos 3x when we will get cos format, when we get by differentiating the sign, by differentiating the sign we are getting the cos. But if we differentiate, argument has to be same, so sin 3x, if we are differentiating we are getting cos 3x. Okay, because same function we want, and multiplying with 3. So what we need to do here, by 3 we multiply and 3 we divided. Okay, because I do integrate this cos 3x, actually the direct integral if I want to write, then it will be sin 3x upon 3. If you are differentiating this function, complete function, we are getting cos 3x guarantee. Clear? So by making that format we are multiplying by and divide by the 3 only. I hope you understood. Okay, if you have any doubt then you can do comments. Thank you for watching.